Decide if the pair of triangles is congruent. If it is, create a flowchart that justifies your decision. So we can see this diagram, and let's remind ourselves of our triangle congruence conditions. We could have side angle side is a congruence condition. Angle side angle is another congruence condition. We could have side side side. Also angle angle and then the side is a congruence condition that works. And the final one is that if you have right triangles and the hypotenuses are congruent and a pair of legs are congruent, then hypotenuse leg also works. So our first question is, do we have enough information in this diagram that we can use one of these triangle congruence conditions? And I see a lot of angles, right? You can see this pair of angles that's marked with a single tick mark. There's another pair of angles that are marked with two tick marks. And they even mark these angles, right? This one here and this one here congruent. So angle, angle, angle would not be enough, right? Angle, angle, angle would just tell me that the triangles are similar to each other. In fact, angle, angle is enough to infer similarity because of the third angle theorem. It would force the third angles to be congruent as well. So we need a side, and because we have this shared side, right, we can see that BC is congruent to itself because of the reflexive property. So we do have angle, side, angle, and I could just say in each one of them, the angle is going to be like the green tick mark, and then we've got the sides that I showed with three tick marks, and then we've got the other angle with this purple. So we do have angle side angle. So now our instructions are to come up with a flowchart proof to show that. So our angles are pretty straightforward because the angles are given. The side that's congruent it's not really complicated, but the side that is congruent, we have to establish that side is congruent by using the reflexive property. So we're going to, if we sketch out our flowchart proof here, we've got our angles, we've got another pair of angles. We're going to have to use the reflexive property to establish, actually that's not going to need an extra bubble, right? We can just say BC is congruent to BC by the reflexive property, so that's enough. And then we're going to come down here and we'll have enough information to go ahead and say that therefore these triangles are congruent to each other. So this is going to flow to here, to here, to here. And I want to show the direction, right? So they're going this direction. We're going to end up saying that these are congruent by angle, side, angle. So that's what we need to have. We need to have a pair of angles and then a pair of congruent sides that are joining, and then another pair of congruent angles. So the important thing here is that the side we have really is connecting those angles in the diagram. It doesn't matter the order that I write them in the flowchart, although it's convenient to write them like that so I can see that I'm matching the angle, side, angle. The first pair of angles I'm going to list is I can't just call it angle B and C because those are bad numbers. So I want to use we'll do the ones with the green tick marks. So the first one I'm going to say is angle DBC. So yeah, I'm talking about this angle right here. This is angle DBC. So I'm going to write angle DBC is congruent to angle. And the one that goes with DBC is ACB with angle ACB. ACB. So the order of those vertices kind of matter. It has to be the case that B is in the center of one and C is in the other. But if you look at those, I think you can understand that those are indeed the angles I'm talking about. Those are the ones that I marked with green. And the reason that those are congruent is because it was just given in the diagram. So we have to have a statement and a reason that supports that statement outside of the bubble. The other thing that we're going to say is that segment BC is congruent to segment BC. And the reason those segments are congruent is because of the reflexive property. For congruent segments. And all I'm saying here is if a segment is certainly congruent to itself, and it turns out that BC is in both of those triangles, so we can use that common segment to establish a pair of congruent sides. And then the final thing we need to establish is that these angles right here, right, the one that I marked in purple, that those are congruent. So let's talk about them correctly. One of them I would call angle, you can see it, ABC. So I'll write angle ABC is congruent to, and the one that matches ABC would be DCB, angle DCB. And those are congruent because they were given also. Again, then the final thing that we have to do is write a valid triangle congruent statement, right? One triangle is congruent to the other. The order of the vertices definitely matters, so I will say that triangle ACB is congruent to, and honestly that order could have been anything, but now that I've picked ACB, the other one that I have to write that goes with ACB would be DBC, triangle DBC, D to B to C, A to C to B. So there we go. There is our flowchart proof, and it really needs to consist of both things. We need to have this diagram, right? This doesn't make sense without that diagram. And then it needs to have the flowchart. Remember, the flowchart has statements in the ovals. Those statements are supported by things that are written off to the side, and then each one of those are flowing into ovals below as supporting evidence for, in this case, why we have enough information to assert angle side angle. I hope you found that helpful.